Okay, so welcome to the OSDC for Perl Programmers course. I prepared a few things. Let me share the screen. That's the best, because I keep forgetting what I'm trying to say. I started to prepare something here, and I'll get to that. But see the OSDC and OSDC Perl. So this is our README file where I put some notes. We talked last week about the detached head, right? We discussed that maybe we'll see the difference and how the whole story about merge and rebase, so we can do that. Reset, stashing, and bisect. So I started to prepare an example for bisect, and we can take a look at that. Okay. And that actually will include the reset as well, because I made a mistake in the preparation. So that's one thing that I think we should cover, or we could cover. The other one is the two other things that one I mentioned on the Slack channel, that I recently saw this post on Reddit about some static website generator. Okay. And I visited the website, which is a GitHub. Okay, so it doesn't have a website, or maybe it has a website, but it didn't link to a website. It should have a website if it's a website generator. Anyway, what I noticed here is that there are no tests for it. Okay, so what I would suggest, or that could be an interesting thing, I think, to try to run this and create a simple test that can be executed and add the GitHub actions for this project. Okay, and so this is a Perl-based static site generator. What I noticed that there are examples here, entries, samples. So the way I would run this test here. Okay, so you can write for any application, you can write unit tests for functions, specific functions, but and if you're starting to write tests as you are developing your code, then it's definitely a good idea to write tests for the functions you are writing. But if you already have an application which is ready, then writing the unit tests seems like a lot of waste of time, because in general, if you already have an application, it's probably working, right? So if it's an application inside a company and it has been deployed, it's probably working quite well. Otherwise, they would have thrown it out the window already. So if you start writing unit tests, they will only test very small subset of the application, and you won't really see the value of those unit tests for a very long time. So it will be a huge investment without seeing value. In those cases, I prefer to start writing what others call end-to-end test, let's say, or integration test, or some much bigger tests. And in this specific case, where you have a static site generator, what I would do is have some example input, run the generator, save the output. Okay, look at it, or either just blindly assume that the output is good. Okay, or if you think that you would like to check it, then check manually or visually that the output is correct. But because I don't really know this project, I would say, okay, I could just blindly assume that whatever it generates now, it is the correct thing. And then I save that, and the next run of the same with the same input should generate exactly the same output. Or that's sort of my assumption. So now I can easily create a couple of these tests, which are end-to-end tests, so they test the whole system. And as people make changes to the application, they can easily verify. I mean, if someone refactors some code, that shouldn't change the output, right? So they can easily verify that the change didn't change the output. That's one thing. And on the other hand, if you make some improvement, you add the new feature, then you can easily verify that the change as reflected in these test cases is exactly as what you wanted. And then you save the new version of the output, and from that point on, that's your test. Okay, so we can do this, and there is the CPAN dashboard that I mentioned in the Perl Weekly in the latest edition. This is a project of Dave Cross, where you can, I'll show mine because that's relatively small. It's for CPAN authors. It will look at all your CPAN packages and show what version you have there, what is the release date, if you have whatever information. So you get a view of your whole thing. It also shows if you have GitHub Actions. It now shows if there is Travis CI, which should be removed because Travis CI doesn't exist anymore really. Maybe other columns should be added, or I think actually that it's a configuration option for each person which columns to show. And other features could be added. So I opened a couple of issues that I thought that would be nice to add to this application. So we could also work on this one. Any preferences here? Shall we start with the Git stuff?
It's okay with me.
Okay. Yaroslav, the present people can have an impact on what we are covering. Okay. So okay. So just tell me if you think it's not a good direction to follow. So here is Git bisect. Okay, you know what bisect is for?
No.
Okay. So the idea is that Yaroslav, you can also answer if you like. I just right now I just see Steve, but just feel free to respond. So the idea is that you have some code, some application, you have tons of commits, fine, and there was some feature that you remember that it worked 2 weeks ago, and suddenly you realize that it doesn't work anymore. Okay, and obviously this means that the feature doesn't have a test, okay, which is a problem itself. But what can we do? In many applications, that's what we have, right? That not everything has tests. We are lucky if half of the things have tests inside a corporation. So we know that it worked. We remember it worked, let's say 2 weeks ago, but it doesn't work now, and we would like to find out why it doesn't work. Okay. Now we can try to go into the code now and try to figure out what's the bug right now, but I think it would be very useful to understand which commit broke this feature, and go there and understand what was the reason this change was made. Because, well, obviously, or I assume that the goal wasn't to break this feature, it was to add some other feature, only the side effect was breaking this feature. So before we fix this bug now, we would like to make sure that we now won't break the other feature that was the reason that this broke. Okay, so what we need to what we can do is go over all the commits between 2 weeks ago, let's say, and today, and for each commit, check whether the bug is there, or if it's still working, or if it's already broken. And if it was only subversion, okay, and so let's say you have 1,000 commits, going over linearly over the 1,000 commits is a lot of time. But if you can do a binary search on the commits, then you go log n. So it will be like how many 10 trials, right? Or 15, or how many? What is the log2 of 1,000? So bisect will let you what bisect will do is you pick an old commit that is still working, a new commit, the latest commit that's not working, then it will find the commit in the middle, in the middle, okay, between these two commits, check it out, you verify if it's working or not. If at that point it's working, then you know that the breakage was after that. If it's not working at that point, then you know that the breakage was before that. And so now you have the search space. So basically, bisect helps you do this binary search. Now, if we were using Subversion, we wouldn't need a tool for this because Subversion just have version numbers, 1, 2, 3, and so on. So you can easily do this just by doing some math, okay, dividing the difference. But because Git doesn't have an incrementing counter in the commits, it won't be easy manually to find the middle one and do this. So bisect provides this feature. So I'll try to show this, but and I started to create an example. So there is this module called mass RPN, which is, oh, Yaroslav, what is RPN?
RPM?
Yeah. It's reverse Polish notation. So yeah, so I didn't even think that's going to be funny today.
Notation Iwaszkiewicz.
Okay, yeah, but it's called Polish notation for some reason. Anyway, so it's a very simple module that at one point I started to maintain it, and it just let's let us see pen code math RPN. So it just takes 109 star would mean multiply 100 by 9. Okay, so it's a reverse Polish notation or reverse Polish calculator, whatever name you would like to give. Okay, and so git status. So now if and I started to make some changes. Okay, so I'll show you what I started to make. In this, this is the master. It has a master branch. That was the most recent thing here, and I started to make some commits. And in order to have a few commits, which are not problematic, have a commit that breaks something and a few more commits, and then so we can try this bisect to find the commit that broke it. But the idea of how to break the system wasn't really a good idea. Okay, so I would like to first fix that. Okay, so before showing bisect, what I'm going to show, I'm going to remove these 3 commits basically. Okay, the commit message is just the number because I was too lazy to give some more longer commit message. Okay, so these numbers are just the commit message. So what I would like to do now is I say git reset and I say head tilde 1. Okay, this will remove the most recent commit. Okay, so I have a commit and I'm going to reset the whole thing, removing the most recent commit. So now if I run this git k again, you will see that you don't have, this was the previous one. You see here we have the commit 4, and now we don't have that commit 4 anymore. Okay, normally you shouldn't do such a thing, okay? Because especially if you pushed out already something, because now you are actually we are, or I am actually changing the history. Okay, and what it did is it put the change, the most recent change here. So I didn't, it's not lost yet. This was the brilliant change I made to the README file, is adding a line with a 4 in it. Okay, so just to make it easy for me, so the commit is not lost yet. It's just not committed anymore. The change not lost is not lost. It's just not committed. And this try PL is not for it. But let's move this out. The try PL. I don't need it. We'll need it later. Okay. So now I really actually want to get rid of this commit. So okay. Okay, so now I also got rid of the commit. But I also would like to get rid of the commit before. So what I do again, I do this again, and the tilde 1 means just to do for the last commit. But I could actually say here 2, 3, 4, any number of 23. Okay, so that would remove the most recent 23 commits. Okay. But I just want now just the last one, and I wanted to show you a different version of this. So if I say here also hard, that means that it will remove the most recent commit and also get rid of the change locally. So I'm going to really lose all the changes. So this way now this way, if I run the git k again, you can see that both 3 and 4 are now removed. Here is the original one. Okay, still open. Okay, so I removed also the commit number 3, but at this time, it's not in git status, it's not even local. So I lost the change totally. So this would you would normally, I mean, I never do this. Okay, I'm too scared of removing without any trace anything. So once in a while, I really, if I make a huge mess, then I still haven't pushed out, then I might do these resets, but it's very rare. So the last thing now that I need is actually making this change again. So I reset the last one because this is the commit I wanted to change. Oh.
Can I ask you a question?
Yes.
Assuming you've
Sure.
done a git reset hard, or even whatever, and you had previously pushed, presumably then the commits are still there. So if you did a git pull, it would just restore it to where you were before you did the reset?
Yes. Yes.
Okay.
Yeah. The problem happens if now you make changes, commits, and then you diverge from what is in the public. And the problem is only if some people start to see that what's in the public and start to build on that. Because now they are building on something that's not in your repository. And presumably what you will want to do is push out your new changes with force, because you have to use force. And then they have already built on something that's gone now. Okay, so imagine that you make a commit, push it out, some people clone it.
Yeah, no, I agree.
Yeah, okay, so that would be really bad. As long as you work alone, or if you can reach easily tell other people, okay, don't look at that, it's fine.
Yeah.
Okay, or you have to know the risks. Okay, that's it.
Yeah.
Okay, so what I wanted to change, and unfortunately this will reveal my bug, but this is what I added. Okay, so this was the original code. Okay, and what I wanted to add is I wanted to skip this push, but I think it's better to say this: if okay, that's fine. So obviously this is a stupid thing to do. Okay, so this code is a very, but I wanted to introduce some bug, and then although I had to use and I keep forgetting bisect. I keep forgetting its name. I had to use bisect several times, and it was a lot of value. But I keep forgetting to save that project for later to show. So I have to make some stupid error in the middle. Okay. So now what I just wanted to show. Okay. So I made some change, and I can run Perl makefile.pl and make test. And test is fine, okay? So now you obviously see that there is a bug in the code, but the tests are fine. So now I can commit it, git add, git status, git commit. Okay, fine, okay. Okay, so this is the commit with the bug that introduces the bug. And then I make some changes here. So, oops, sorry, that's not what I wanted. So I just add 2 more lines just so we have some commits there. Okay, and I add line 4, add readme. Okay, so here is, so now you can go back to the story, because now is where I prepared the example. So here we are in the project, and you say, okay, if I run all my tests, make test, everything works fine, right? And then somebody comes by and says, okay, but in this case, it doesn't work. So they come up with this one. That's why we had the try PL here. Let's move it here. Okay. So I write Perl. Actually, I have to do Perl 5 lib equal lib and Perl try to make sure that it's using the one that's inside here, not the one that I already installed. Okay. So what is this try PL? The try PL says 391 1 plus. So I expect here 392, right? Because adding 1. And I run it, and it's 393. Okay. So there is a bug here, right? And now we can add this. And now we have 2 choices. One, of course, trying to figure out what is the bug. But before that, we would like to find where the bug is, okay? Find what introduced the bug, which change, okay? So in order to do that, we need to have an easy way to verify that we have the bug or not, okay? And then we start using bisect, okay? So I can use either this. So I can either change this try PL, or I can turn it into a test. Okay, so let's convert this into a test. So try, and let's call it T391. Okay, .t, and why did I call 5? Where did I say this? Why is the 5 there? I don't know. Well, I wanted something there, but I didn't remember what. So 391. Okay. So how do we write it? Vim. How do we make it a test? Let's actually see how the other test written. Test T. This one, it uses, so this is the prefix. Okay. I would personally prefer to import only the RPN, and then basically this should be the test. Is RPN equal to 392, right? And done testing. That's it. Okay, let's try this one first. So if I have now this OK1, and I write make test, then it doesn't like us. Planned to test. No warning. Sorry, I don't need the warnings. Okay. So we have now I just wrote a simple script that loads test more, loads this, and just to verify that it's passing this way. Okay, that I wrote the proper format of the test. I had this. Now I replace it with a real test. Okay. And I run this, and it fails. Okay, and we got 390. So it's a good test, right? To verify that the project works or not. And so git status, we have this. If I go and git log, okay, and then I go back to some old version. Okay, I remember that here in 2012. It was still working. Okay, so git checkout, and I remember, but before I really claim that it worked, I would like to verify it. So I check out that commit and run the test again. Okay, and now the test passes. So I know that at this point it was still working. Okay, so I go back to the master branch, because that's where. What is the name? Git checkout master. Okay, because that's where we're going to start. So I say git bisect. Actually, I think I can say help, and then it will tell me how can I use it. So I can I say git bisect start. That's how I start the process, and then for each commit, I will tell it if it's bad or good. Okay. Alternatively, I could use the word new or old, because sometimes the thing is not that being bad or not, but let's go for bad and good. So with the command git bisect, I can mark a specific commit, whether it's a good commit or a bad commit. So here I say git bisect start. Okay, because I would like to start this whole process. Fine. Now I verify, I'm at the master branch, the top. I say make test. And why does it pass? Because not in the, sorry, git checkout demo. I need to go to the demo branch. Okay, so here at this point, I know that it's broken. Okay, and this commit is broken. So I say git bisect bad, because it's a bad commit. That's how I mark it. And now I go back to some other point in history. I can go to this one, which I already tried, check it out, run the make test again. Okay, I see it's good. And now I say git bisect good. Okay, so now what it says, okay, between the commit that we marked bad and this commit, there are 8 commits, revisions. Okay, and it immediately checked out a new commit here and said, okay, go ahead. This is the middle. Try to verify here. So what I do this here now, I run, okay, so far, is it okay? So I marked the good one, I marked the bad one, which is the most recent commit. I marked an old one, which is a good one. And now it gave me one in the middle. So I run make test. It's good. So I just mark it as a good. And it gives me a new one. Okay. And it also tells me how many steps I still have. Okay. And I run the test again, and it's still good. So I mark it as good. And then I say make test. Sorry, yeah, make test is still good. Okay. I run make test, and now it's broken. Okay. So I can mark it as bad if I find that one. Okay. And here is the one that is making a mistake. Okay, so I run the make test, it fails, I mark it as bad, and then it tells me, okay, if you found it. Okay, this is the commit that broke that feature. Okay, and then and yes, making a mistake. This was the commit where I introduced the mistake. Okay. Of course, if I was going to 1,000 commits, then you would see it how much faster than 1,000 it gets. Okay, so it's very fast. I mean, it's log n of the number of commits you have, where you think it was still working and where you are now. Questions here?
If I understand, Git besides can enumerate repository through commits and help us to discover where is the problem.
Yes, exactly. Basically, I think what it does, it takes all the commits based on date. And now you see, it's okay, it sees 100 commits and it goes to the middle one. And so I don't know if it does exactly by date or how, but it creates, I guess it's date because that's how it can easily create a linear flow of commits, even though you might have branches all over the place. Okay. So.
No, it's really useful, actually.
Yeah, I think it's super useful. And of course, at this point, okay, so at this point, we are git status. We are at a detached head, okay? So we are on the commit that broke the code. So we won't go ahead and make the fixes here, but we can see, okay, so now we can use git show to see what is the actual change. And now you can see who committed it, who made these changes. You can read the explanation, why they made the changes. And then from this, you can probably much more easily understand why that change broke your case, your test case, that feature. Okay, so now that I understand, I would go to git check out the demo, so the top of my branch or master or wherever you are. Okay, so whatever branch you are working, and make the fix here. Okay, and okay. And then I would probably also add the test because, okay, now I just wrote a test that verifies that feature. Okay. So one more thing I would do is git bisect reset. So I actually checked out the master branch for some reason. I don't know why. Because I started it on the master branch. So, okay, at the end, you probably want to do git bisect reset. And the way now to fix the code actually can be two different ways. If the change had some valid parts, but also something that broke your code, then you go and make that change. that will keep the valid part, but fix the broken one. In my case, the whole change was bad, right? So what I could do at this point, I can't remove that change, right? Because I already built on top of it. So I can't just remove something in the middle of the history. But I can say git revert, and then take that, where is the, I think, this is the SHA, right? Yes, this is the SHA. Okay. So, and it's going to revert that specific commit. So now I'm going to commit it, and you will see that git show head. So this is the most recent commit, is the same thing, is just removing that commit. So I can't, sorry, removing the change. The commit is there, so still git k all, if I look at this, I can still see here is making the mistake and here is removing that change or reverting that change. Okay, but it's basically applying that change in the opposite way. Okay, because I couldn't just remove from here because, well, 3 and 4 already built on top of it, and in a more real-life scenario, that would not be just two commits that built on top of it, but 2,000. Okay, so you can't just remove something there in the middle. But this way you can, it's basically doing a git diff and then committing in that other direction. Questions?
In a complicated situation, more complicated situation, you can imagine that causing conflicts. I mean, you had a very simple thing where it was one file and one simple change.
Yeah, but
if it was a thing over multiple files, that maybe other people had.
It's probably
changed.
Okay, so most likely, again, in my case, I made a change specifically to break the code. Okay, and so the fix was reverting that change. In a real life situation, and maybe I should improve this example of having some real improvement at the same time while I'm breaking the code. Okay, and in that case, I can't revert the whole commit. Okay, I need to just fix the bug, okay, and commit that one. Okay.
Okay. Okay.
So that would be, so that's an improvement for this demo. Right. Okay, I put a note for myself, so I improved this example for another time. Okay, so that's git bisect. Okay, and we also saw reset in the same time, and we saw revert. Okay, so we also saw git revert in the same thing. Now git stash, okay, git stash, I guess you know, right? Or do you know, or it's a question?
No, I think I'd like you to talk about git stash.
Okay, so I'll show a little bit about it, and then you can. So basically, git stash list. So I have one thing in the stash now that I put aside before. I think that I tried to make some changes. So and let me make a change here. README 5. So a couple of things. Okay, so why do we need stash? you probably work on some code, some changes, and then in the middle of the change, you suddenly need to make some different change in the same code base. So you don't want to lose your current changes, your current changes. You don't want to commit them because you haven't finished yet. So how can you do this? One way that people do is work on the same code and the same change, and then later maybe they use the manual, what is it called, that you git add -a that we did last time, that you handpick the hooks that you want to add to the commit. But that's a headache, okay? And besides, maybe the tests are not passing currently because your changes, you're doing some change that just broke the test, and now suddenly you need to fix something else. Or you realize maybe that you need some refactoring before you continue your change, because it will be easier, your change, if you make some refactoring first, okay? Or you just found a typo that you want to fix in the documentation before you continue. So you can run git stash, and git stash would put aside all the files that you changed. So I run git stash, and it put away all the files that I changed. If I run git status, you can see that the files that I didn't, that Git wasn't tracking yet, so that are new, they weren't put aside, which is not usually not really what we would like. Okay, actually we encountered some strange behavior with that last time, but this didn't put it away. Now, if I run git stash list, it will show me all the things that I put away this way. Okay, and it's a stack. So the most recent one that I put away is stash 0, and the one that I did earlier is stash 1. What I don't really like, or maybe there's no better way, is that the default message here is the most recent commit at the time of the stash, which is usually, I don't know if it's true, but for me it's usually quite meaningless. Okay, so from the text I don't know what the stash contains, but when you do git stash, actually I think if I run help, if I write it correctly, then it will tell you that you can also give a message. Okay, so this text, what you see here, is the default, but you could give a message explaining what is in that stash. And you can also say git show, and you say which one to show. Let's say, okay, so if you say git show, it will show the whatever it is the most recent. Is it the most recent? Oh no, sorry, git stash show. Git stash show. I was confused for a second because it was showing the last commit. Now, git stash show shows the most recent stash, and if you also give -p, it also shows the diff. So what is really the change? But this is the most recent stash. If I also give here the ID of the stash, which is, I don't know how much you need to give here, then this is that specific one. And I can also say -p, and now it shows me that specific thing that I put away in the stash earlier. So even though this is a stack, you can access the ones below in that stack. Okay, so you can see what is in your stash, not just the most recent one, but the earlier ones as well. Okay, and you can say git stash pop, that will pop out the most recent one, and make the changes locally. So what if I would like to stash away just the to-do file? So I think I can do this: git stash push minus u to do, or maybe it's not that direction. Yeah, git status. Okay, so I showed two things here actually. One of them is the minus u flag will tell stash to stash also things that are not tracked, so new files. That's the minus u. And the push allows you to select specific files you would like to put in the stash. Because sometimes happens that you have like 4 files already editing, because what you did is not what. So you started a change, and then without creating a stash, you started a different change, and then suddenly realized, I should put some of these files in the stash. Okay, and if you just say git stash, it will put everything in the stash. But if you say git stash push and the names of the files, then it will only stash those, which is useful. And the minus u tells the git stash. So the minus u is include untracked. So this is the same. Okay, include untracked files. That's the minus u. Okay, so let's see one more thing. I say git stash now, minus u. What will it do? What will it stash? The change. I have a change in the README file, and I have a new file called t something.
Status. So I'm just trying hard to read the screen.
I can enlarge if that. So
I guess just you. So it's going to do the README. Yeah, both of them, README and the t slash whatever. Yeah.
Yeah, I think it's both, because it just stash everything. Okay. So now if I run git status, you can see it's clean. And if I run git stash list, then okay, I have this. Okay, let's see this git stash pop. Okay, I got back the 2 files, and now let's do this git stash minus u minus m adding test and readme. Okay, git stash list, git stash list. Okay, so you can see now that I could set this message to something more meaningful to me. Okay, so let's say what we had there is that I was working on this README file, and then suddenly I realized I have to do some other changes in the README file, which are not related to this change. So I put away the README file with this git stash, and then I edit the README file. Let's say add text. Okay, so I have now here this change. I can now commit this change, add text. Okay, and if I run git stash pop, so now, right, it saved the difference. It saved the change. It didn't save the README file. It saved the change, or at least for all purposes. So when I pop it out, it will merge the changes that are saved in the stash with the changes that I made just now to the README file. So I run git stash and I open the README, and now it has both this add text that I already committed and the extra line 5 that was in the stash. Okay, this breaks down if I happen to edit the same line, and then it will tell you what it will do. Let's see what it will do. Okay, actually, let's see that one. Okay, so let's run this git stash again. Any questions up to here? Questions, comments before I continue?
Okay.
Okay. Git stash.
Wow.
Yes, something?
Not now, after watching again video.
Okay. So git stash -u. I saved it again. Now I go to this README file, and instead of 5, I add here X. Okay, fine. Git add, git commit. First of all, I think if git commit -m readme. Okay. Now I say git stash pop. Okay, but we actually have a conflict because we edited the same line. So it tells me there is a conflict, okay? And it also so it brought the change out from the stash. It tried to merge them, it failed. We'll see the conflict in the README file, but it also kept the whole stash in the stash. So the whole change is also kept in the stash. So I didn't lose. So I can now do either I can remove all the changes that I have here now, basically going back to what I had before the git stash pop, and then figure out what else to do. Or I can fix the conflict and then throw away that what's in the stash, because now I already have here. So the README was modified, right? And it says both modified. So if I open the README, it will tell me, okay, the upstream had this, and the stash brought this. Okay, and now, well, it's up to me. I have to decide what should be there, right? Maybe what should be there is actually this. Okay, maybe this should be there. Okay, I mean, okay, so I save this, and then I say git add readme, and that's it, to mark the resolution. Okay, I could also say git restore -staged file to unstage it. Okay, or whatever. But this is how. So it now fixed the. I fixed the conflict. Okay, and then there is the git stash list and git stash show -p. So this was this is what we have in the stash, but we don't need it anymore, right? Because we already integrated locally. So I can say git stash drop. Okay, and I drop the most recent stash without bringing it locally. Okay, so the reason it saves, it doesn't, when I said git stash pop, it didn't remove it, is because there was a conflict. And it says, okay, let's keep it keep it intact in the stash as long as you, the user, decide that it's fine, you resolve the conflict, or you say, okay, let's get back to where we were and make some changes before we pop out the stash again. Okay, or we might want to manually copy paste the changes from the stash if we are really lost with the conflict. Okay, questions about this whole stash thing?
I guess can you pop down? Can you get the next one down? So you've got 3 there on your stack, or you had. Could you get the second one down? Stash 2 down?
So you're asking if I can say git stash pop. I think it's 2, and I think it 1 actually. So 2 has only 2 entries, so 2 is not working, right? But I can say 1. So this is 0 and 1. Okay, so it's
Okay.
okay, so just the numbers. Okay, so now I popped out, and this if I say git stash list, then I have just the making just so the what was the 0 is now still the 0 because I popped out something that wasn't the first, wasn't the topmost. Okay. So it's even though we call it a stack, but you can pop from any place of it. Okay.
Okay.
So it's not really just it's only a stack when you git stash and then it pushes. So the default so the default operation behaves as if it was a stack, but you can play around with it. And I see there is also store and create and clear and branch. So there are a couple of other things here that I don't know. Okay.
Okay.
And git bisect help. Yeah, there's also here a couple of things that we haven't seen. So we just saw one thing about the bisect I also want to add, but let's focus on the stash if you have any more questions.
Nope.
Okay. Yaroslav? No. So one thing so there are a couple of more things in the bisect that I haven't covered, but one thing I would like to mention. So as you are going from as you are doing this bisect and it checks out a commit, and then you try the test, and it either fails or not, right? And then based on that, you mark it as git bisect bad or good. That's fine, except that you will encounter probably a commit that fails, but not because of your bug. Maybe you can't even test that. Okay, so maybe not that it fails not because of your of that bug. Maybe you can't test that because there was a syntax error in the code someone committed. Okay, and the git bisect just brings you out that commit that was so broken that it had a syntax error. So you can't verify whether it's a good or bad from your point of view, okay, about the issue that you're working on. So in that case, what you do is say git bisect skip.
Okay.
And the bisect will understand that you couldn't decide. And it will give you probably one above or one below in the commits. Okay, so one immediately, so in this linear thing that it created, and then you can try that, and then if that in that case you can already verify whether it's good or bad, then you mark it good or bad, and it will continue. And if that's still broken, and you can't verify, then you can say skip again, and then it will figure it out. Okay, so that's another thing that was pretty useful for me in some cases. And one thing here, so what I showed, it was a very, besides the fact that the bug itself was stupid and small and made up and whatever, the way I verified was so easy. In real life, okay, in a real project, you might need to do a lot of work in order to verify the code, to verify that the bug exists or not in that case. So it might be not that easy as here. So I had some system where I had to rerun the whole compilation of something, and it took me, I don't know, a minute to deploy the code somewhere, and only there I could check it, because it wasn't easy to test. Okay, that's the point. Okay, so if it's something that's easy to test, that's fine. In many cases you can't. Sometimes I had to manually verify whether the bug is there or not, because I couldn't write a test, or it wasn't, it didn't seem worse to write an actually automated test for it. So I manually check the result, whether it's good or bad. Okay. So, and whatever, but still was much better than going over all the 1,000 commits we had.
Yeah.
Okay, let's have a break now.
Okay.
Like, let's say 5 minutes, and then we can continue and do one of the other things we can try, or if you can think about something, that we can do that. Okay, so
Okay.
5 minutes. Okay. So see you in 5.